Now we get the resultant of a system of forces like this. If we get, for example, say 3 forces like these, one force of 100 Newton, making an angle 30 degrees, and one force of 140, making an angle of 45 degrees. And there's one angle P and there's one force P, right? And 3 forces act at a point, given that the point is in equilibrium. Here we are going, supposed to add them the 3, but we are given that the sum of them is 0 because they are in equilibrium, and this angle is theta. Later we have another example where the forces don't make equilibrium. What are we going to do is this. We are going to add all the forces horizontally, and then to add all the forces vertically. The sum of the forces horizontally should be 0, and the sum of the forces vertically should be 0. Or the sum of the forces horizontally, because we are not getting the resultant here, but we are here having equilibrium. So we say the sum of the forces horizontally to the right equal horizontally to the left. Then 100 cosine 30 plus P cosine theta equal 140 cosine 45. Right? From this equation, we will get the value of P cosine theta equal 12.392. Then we say 100 sine 30 plus 140 sine 45 equal P sine theta. We will get the value of P sine theta equal, P sine theta will be equal 148.994. We write the two equations, we're dividing the two equations. We got one P sine and one P cosine, so we divide them. P sine theta divided by P cosine theta equal 148.994 divided by 12.392. We get from this that tan theta equal 12.023, from which we get the angle theta is 85.245 or 25. We substitute the value of theta in one of the equations. We got P sine theta equal 148.994, and we have now the angle theta. We will get the value of P. We will get P equal 150 Newton. Therefore, we got the value of P and we got the angle theta. Now, if we have a group of forces and we wanted to find the resultant of these group of forces. Right. Now, before that, we would like to explain one thing more here. This force can be done by vectors. This problem can be solved by vectors. How? Let us draw the forces one after the other. If we draw the forces one after the other, then they should close a triangle. Why? Because the sum of the three forces is 0. Therefore, if the sum of the forces is 0, therefore, if we draw the three forces vectorially and we add them, the sum of them should be 0, means the line, okay, if we draw the first vector with a line, second vector with a line, the third vector should go to the same starting point, indicating that the resultant is 0. Let us try to do it. Now, the first force we draw is, let us draw it one by one. Okay? Now, I draw the first force, say 100 Newton, making 30 degrees like this. This is 100, and this is making 30 degrees with this. Then we are going to draw a force of 140, making 45 degrees. Remember, this is 30, this is 30. You make now an angle of 45 degrees like this. Okay? Now, the force of 140 making 45 degrees there. Then we draw the third force, which is this one. This is a third force which is supposed to close the triangle. If this angle 45, this angle is 45. If this angle is 30, then this angle is 60. Right? Then now we have, right, the all angles of the triangle and one side missing force P. So what are we going to do? We are going to use a sine rule. So I'm going to say P divided by sine 75 equal 140 divided by sine 60. And from this we can get the value of the force P. And we can get the value of the force P. Now again, the first force, this is making 75, right? And this is, okay. Now, we don't know the direction of that force, actual fact. And this direction we don't know, right? And this direction we don't know, okay, because we don't know yet the angle theta. Sorry. So if this angle is theta, and this angle also is not known, therefore it is P over sine 75, but we don't have the other, right, forces. We can get the value of P in actual fact using the cosine rule, and then we can use sine rule to get, yes, sorry for that. This angle is what, this is 140, and this 100, this is 140, and this is this angle, but this is not vertical. Therefore, this angle is not 45. and this angle is 60, which is a vertical, this is not vertical, right? And therefore we say this. We say the following. We say P, right? Let us draw it again from the beginning, okay? Let us draw it from the beginning. So we make it clearly drawn. The problem is this. We have the following. We have the first force is 100 making 30 degrees. Okay? Therefore, the first force is 100 making 30 degrees. Fine. 100 making 30 degrees. Then the force is 140, right? Therefore, this angle is 30. There's a force there, okay? That force there making 45 degrees, and it is 140. This is the third force, which will close the triangle, okay? Which we know, using cosine rule, we can get its magnitude. This is P. So if we say P square equal, right, 100 square plus 140 square minus twice 100 times 140 cosine 75. We will get the value of P. P will come out to be 150. Then we need to know its direction. We need to know here it is angle P, right, in the diagram makes angle theta with the horizontal, say this angle there is theta. You want to know what is this angle. So what are we going to do is we are going to use the sine rule. We are going to say P divided by sine 75 equal 140 divided by sine this angle, we call it alpha. With the sine rule, you get the value of the angle alpha. Once we got the value of angle alpha, we subtract angle theta equal 180 minus alpha plus 30, from which we'll get the value of the angle theta, which will be 85.3 degrees. This is how we solve it, right, by triangle of forces. We call this triangle of forces. Any three forces, right, if they were drawn one after the other, the three forces must complete the triangle. Any three forces in equilibrium, if they were added together, they should complete a triangle. We'll try some more examples on this later on. Now, we are going to take the example of a number of forces to get the resultant of a number of forces. For example, we have to get the resultant, right, of these forces, right, resultant of a system of forces. Now, we have the following. We are given one force 6 inclined at an angle 40 degrees, one angle 5 one angle 5 now this angle makes angle 45 degrees. It is 5 Newton, and one angle vertical 10 Newton. And we want to find the resultant of these forces. So what are we going to say to do is, we're going to say what is sigma fx. What is the meaning sigma fx? The sum of all horizontal forces equal to, now the 5 cosine 45 plus the force 6 cosine 40, and the 10 is only vertical, so it doesn't have horizontal component. So we get the sum of fx, and we get the sum of fx. Then we get the sum of fy. The sum of fy, up positive, down negative, 6 sine 40 plus 10, all of it is vertical. When a force acts along the y-axis, all of it is vertical. Minus 5 sine 45. The component with the x, if the angle with the x is cosine, well, component along the y is sine. If force 5, the angle with the x, if the x is cosine and the y is sine. And we get the sigma fy. After we get the sum sigma fx and sigma fy, we say the force F is the square root of sigma fx square plus sigma fy square. From this, we can get the value of F. Then, to get the angle the resultant makes, the resultant has sigma fx in that direction and sigma fy in that direction. This is going to be the resultant. The angle theta the resultant makes with the x-axis, tan theta equal sigma fy over sigma fx. And then you know the resultant and you know its direction exactly, right? We have found the magnitude of the force and we have found its direction by getting the angle with the x-axis. Now we covered number of items, right? We covered now here we covered the adding forces together, right? When the forces are in equilibrium, 3 forces, where more forces, how to get the resultant. We come to one last point to consider is what will happen if a body is placed, is a particle is placed on what we call inclined plane. If a particle is placed on an inclined plane like this, its weight acts vertically, mg. The normal reaction acts perpendicular to the plane. Remember, normal reaction means normal to the plane, yani perpendicular to the plane. R is perpendicular to the plane. But the weight is a gravitational attraction. and the gravitational attraction is vertical. Usually this body will be pulled up, say, by a force. We are pulling, say, this body by a force up, and we wanted to find, say, the acceleration. Therefore, we are pulling this weight, say, by a force up in order, driving force D, and the body to move up. And we are asked to find the acceleration of the plane. Here, when we consider forces, right, in two directions, if we consider forces in the horizontal and vertical direction, there are too many forces to resolve. And therefore, in this case, we decided to make something better. We decided to choose our axes. The x-axis along the plane and the y-axis perpendicular to the plane. If all problems of a particle placed on an inclined plane, we are not going to choose our axes horizontal and vertical. No. We are going to choose the axes, one along the plane and one is perpendicular to the plane. And we resolve forces in these directions. So we find most of the forces already in these directions except the weight of the body. If the only force we need to resolve is the weight of the body. And the weight of the body, say, if this angle is theta, then this angle also is theta. Why? Because this angle plus this one makes 90 degrees, and these two makes 90 degrees. Therefore, this is 90 degrees here, and this is 90 degrees here. Therefore, these two angles are complement of the same angle, therefore are equal. Therefore, when we resolve the weight, this component of the weight is mg cosine theta, because the angle theta is with this axis. The angle theta now is with this axis, with the y-axis, but the y component is the cosine. And this component is mg sine theta. And accordingly, we're going to say this. Now, forces in the x direction. We have the forces in the x direction is going to be d minus mg sine theta equal ma. And in the vertical direction, we have a balance of forces because there's no motion. Even the forces are balanced. Even R equal mg cosine theta. Even every time we have an inclined plane, remember that we are going to use the plane is the x direction and the perpendicular to the plane is the y direction. Let us take an example on this. Example 6. We have a particle of mass m is pushed up a small smooth slope by a force of magnitude 5g acting at an angle of 60 to the slope. Now, and the slope, right, he said, okay, causing the particle to accelerate up the slope at point 5. Right, find the mass of the particle. In the diagram, the slope makes 30 degrees with the horizontal. This is 30 degrees. And this is the particle. The force acting on the particle making 60 degrees like this, and the force 5G making 60 degrees. طبعا this force will be extended to the other side, and this is angle 60, this will be 60 degrees, and the force will be 5G. The weight of the particle is mg. The weight of the particle mg the normal reaction is R. This is mg. We know that we are going to resolve the forces in this direction and in this direction. This component of the weight is mg sine 30, and this component is mg cosine 30. The 5G force given to us is resolved into 5G cosine 60, and one in that direction is 5G sine 60. In the direction of motion, we have the following. In the direction of motion, we have the equation, right? It's been asked, we're given that the acceleration is 0.5. So in the direction of motion, 5G cosine 60 minus mg sine 30 equal 5G. The mass is m. The mass is m times the acceleration is 0.5. From this equation, we got 2.5G equal m open bracket 0.5 plus g sine 30. Okay. Sine 30. From this equation, we got, right, g mg 2.5g, right, equal to m cancels, right, because this is 5, right, minus mg plus we will have the equation multiplying by 2, you will get 5g equal m times 1 plus g, 9.8. Right, from this equation, we've got the mass m equal to 5g dividing by 1 plus 9.8. And we got this equal to 4.54 kilogram. Therefore, this kind of problems of, we call it, of inclined plane. Now, if we have one more force about inclined plane, example 7 in the book, an inclined plane particle P, there's a force of 4 Newton acting up, and the normal action is R, and the weight of the particle is 2 kilogram, its weight is 2g, and the angle inclination is alpha. We are given that tan alpha equal 3/4. So we draw a triangle. This angle alpha, this is 3, this is 4, this is 5. Now, we are given that, okay, right, say that the particle P of mass 2 kilogram moving on a smooth slope and is being acted upon by a force of 4N, that's parallel to the slope, right. Work out the acceleration of the particle. Okay. Now, we are going to say that 4 minus 2g sine alpha equal 2a. That's it. This is 2g sine alpha. 4 minus 2g and sine alpha is 3/5 equal to a.